Next, we're going to see an example of differential equation problem from the 2017 free response question number 4. It is about a boiled potato that is taken from a pot on the stove and left to cool in the kitchen. We are told that there is a model dH dt equals to negative 1/4 times h minus 27, where ht is measured in degrees Celsius, and h of 0 is 91. We can use those information to solve for part A. At t equals to 0, h equals to 91, and we can plug that back into the equation of dH dt and get us the slope of negative 16, which is the slope of the tangent line at t equals to 0. Then we can figure out the equation to the tangent line by using point-slope form. So we will get y minus 91 equals to negative 16t minus 0. Thus, h of 3 will approximately equals to h of 0, which is 91, minus 16 times delta x, which is 3, and gives us the answer of 43 in degrees Celsius. For part B, we are asked to find the second derivative of ht and to determine whether the answer in part A is underestimate or overestimate. By taking the derivative of dH dt, we can get the second derivative of ht, which is negative 1/4 times dH dt. As we know the equation for dH dt from the question, we can plug that back into the answer and then get a simplified version, which is 1/16 times h minus 27. The question also tells us that the internal temperature of the potato is greater than 27 degrees Celsius for all times t is greater than 0. The second derivative of ht will also be greater than 0, for h minus 27 will always be greater than 0 on the interval of between 0 and 3. This tells us that ht is concave up, which means that the tangent line is below the curve, and thus the answer in part A is underestimate. For part C, we are given another model, which is gt, and with the differential equation of dg dt equals to negative g minus 27 to the 2/3 power, and initial value of g0 equals to 91. And the question is asking us to find the expression for gt. To solve for g, we will need to separate g and t onto both sides of the equation and then take the integral on both sides. We will get the equation of 3 times g minus 27 to the 1/3 power equals to negative t plus c. By plugging in g0 equals to 91, we get that c is equals to 12. Thus, we can plug 12 back into the equation and simplify it to get gt, which is equals to 27 plus negative 1/3 t plus 4 to the 3rd power. And then to solve for g at t equals to 3, we get 54 degrees Celsius.